Find the minimum water content in a sample of soil such that the dry unit weight is at least 90% of the maximum dry unit weight. In this problem, we've been provided laboratory data from a compaction test, which includes the total unit weight of the soil at 6 separate water contents. To solve problems like these, we plot the water content by the dry unit weight for all of our data. Next, we plot a line of best fit through this data set and determine a third-degree polynomial expression for the dry unit weight, given the water content. The optimum water content will occur where the first derivative of this equation is 0 and the second derivative of this equation is negative. The dry unit weight, corresponding to the optimum water content, is the maximum dry unit weight. And we can compute 90% of the maximum dry unit weight and plot a horizontal line at this value and identify the water contents corresponding to 90% of the maximum dry unit weight. These values can be thought of as the minimum and maximum allowable water content values, if 90% is the minimum allowable compaction. Since we're asked to find the minimum water content value, which meets this condition, we'll solve for the value on the left. Now let's look at our laboratory data. We've been given the water content, which will be plotted along the horizontal axis. We haven't been provided the dry unit weight values, but we do know the total unit weight values, and we can solve for the dry unit weight by dividing the total unit weight by the quantity 1 plus the water content. So let's add a third column to our data table for the dry unit weight. We first convert the water content to decimals, and then we start with our first test point, which has a water content of 10% and a total unit weight of 102 pounds per cubic feet. This gives us a dry unit weight of 92.7 pounds per cubic feet. So we add this value to our table. When this process is repeated for the second point, our dry unit weight is 101.8 pounds per cubic feet, and the value is added. We continue this process for all 6 test points. We can now remove the middle column of data containing the total unit weight and move our dry unit weight over. Now we're ready to plot our laboratory data with water content values of 10%, 12%, 14%, 16%, 18%, and 20%. The line of best fit is added, and using calculus, or the eyeball, 14% was determined to be the optimum water content. Therefore, the maximum dry unit weight of the soil is 107.9 pounds per cubic feet. 90% of the maximum dry unit weight is 97.1 pounds per cubic feet. A horizontal line is traced across the plot at 97.1 pounds per cubic feet. Where this line crosses the best fit line, we trace down to identify the water contents associated with 90% of the maximum dry unit weight. The smaller of these two values is 11%. When looking back at the possible solutions, the answer is B.